Okay, let's hope this is gonna work this time around. We've got an entirely new setup going pretty much. Still using the same crappy components, but give me a moment to figure out whether or not we're actually online. Now we've got a stream. Good. Right, so for starters, primer. I've got a fancy new microphone and stuff going on. Let me know if the audio quality is absolutely abhorrent. Sounds pretty okay to me, but in the past my feedback for this has not been very reliable. So, people are showing up in the chat. Excellent. Hello. So, what we've got today, once I can get all my leads out of the way so I can actually see what I'm doing. What we've got today is an Antec, I think this is a high current gamer, 900 watt computer power supply, which has some issues where it will not power on reliably. It will turn on for a sec and then turn off again. Someone obviously has been in this before, since the case isn't installed right, so I got no idea what to expect out of this. Could be some horrors from the deep, but for starters, let's just try and power it on and see what it does. So power switch off. Let's get some electricity into this. And let's turn on the tools so that we've actually got something to work with once we get into this thing. Righto, I've got my power button here, power on there, power on there, so we've got fan spin, a lot of fan spin, and in the past it's turned off within 20 seconds every time. It has put out decent quality voltages while it has been running. Let's give that a bit of a check. Meter in there. 12.24, that's fine. And they turned off for no real reason. I've tried using it with a computer connected, and that did nothing, so it's not some unload thing going on. It is a reasonably old power supply, so it could actually be suffering from bad caps if it is a bad build quality unit. We can't rule that out. We're going to have to test those if they look cheap. And it says that something about my streaming thing is broken, so I'm hoping we're not going to go offline. We're just going to have to deal with that for the time being. Let me know, again, I've got an entirely reset streaming setup. Let me know if everything's horribly wrong and everything's falling apart, because I don't have any good feedback on that. Well, that came in apart very easily. It was just held together with two screws. Can we get rid of a fan? Not easily. This does not look like a very easy repair, because this does look like a decent quality power supply. Let's zoom in on that a bit. Let's move the camera. There we go. So we've got decent quality capacitors, it seems, all around. I can see Rubicon and Chemicon. I think all of them are good quality. This thing is quite dusty, so it has seen a fair few hours of use, so we can't rule out possible wear-related issues, but I wouldn't quite expect that. Since it does power on, I would expect the PSU circuit to work. We could check the voltage across these capacitors, make sure it's about 380 volts, which is what it's supposed to be. And yeah, perhaps that's where we should start. It seems to be relatively easy to run this thing outside of a case. The power inlet comes off on the inside, which is refreshing. because that means we can actually power it outside of a case, which is not always the case with these cheaper PC power supplies. Often the power connector goes on the outside and you have to physically desolder it in order to actually get the PCB out. There's no connector holding the there's no connector for the power inlet, so it's yeah, it's not really made to come apart, but these things never are. It's supposed to be a cheap disposable unit. We do need to desolder the power switch though, because that's soldered on, and we can't. It comes out towards the outside, so nothing to do about that. What's the chat say? Everyone's saying everything looks fine. Well, that's good. Greetings from Portugal. Hello, Portugal. People are talking about checking the power good line. Oh, that's a fair point, but I'm not sure what would we actually gain from doing that. That's just some internal diagnostics. I don't quite care whether or not the power good line is on, since my power switch should keep it on anyway. Also, I don't know which color wire it is, and I'm too lazy to look that up. Well, a lot of people are showing up for this. Weird. Hello, everybody. Again, do point it out if the stream is having horrible issues, because we are dealing with a rather revised setup. That's one wire off. Let's get some more light in here. That's better. That's better. And let's give the other one off as well. Then we can just solder these together in order to power the unit on outside the case. Yeah. Refreshingly easy to get apart this thing. Most of the PC power supplies I've worked on have not been this manageable, really. They're just pretty much permanently bolted into the case, never to come out again. Someone's saying very good live show. Hi there. Hello, FXN Fun Extreme Network. I don't think you've been here long enough to judge the quality of this though. Video quality wise we should be doing pretty okay though, because I've got some horrible cobbled together 4G connection show. So we've got like 2 megabit of upload now, which is twice what we've had in the past. 2 megabits. How does this come apart? It has a weird plastic thing down there, which seems to be keeping the board in. Let's just monge that off with some pliers if we got them. Where are my pliers? I have no idea how far the last person who worked on this got. I think it belonged to like some kid, so they probably just took the case off and didn't bother doing anything else. Is this just spinning? No, it's coming. Slowly but surely. Come on. Plastic, like M3 threaded thing, this thing just keeps on spinning forever. Sleepy Sloths says, hey man. Hey Sleepy Sloths, how's it going? There we go. That's an odd part. Oh, and now it's gone forever. Some kind of plastic board mainty thing. Well, I think the PCB should be pretty liberated by now. They should just pop out. Oh no, one more zip tie. Snap. Shish, this thing is very dusty. Very dusty indeed. Ah, we do see this thing has a rather dodgy looking solder joint here. But it's so dusty, I'm going to go to the other room and blow the dust out of it. And because we've now got, check this out, fancy wireless microphone, that means I can keep monologuing while doing that and you can listen to my compressor. Which is a big step up from what we've had in the past. Geez, I feel like a big budget show now. All we're missing is like a wireless GoPro. So brace for loud noises. I'm going to be wearing hearing protection for this, but I don't have anything for a mic. Oh, this thing is dusty. Very dusty. That's the innards. I'm going to do the case as well, just to have it done. There we go. That's the laid part done with. I hope I didn't blow your ears out. Alright, let's move forward. Wow, 81 people. That's almost a record for one of these streams. I should make some effort to actually make this good. Someone says, looks like I've been upgrading my computer. Not quite, no. Although I have replaced the video card in the streaming PC you're watching me through, since one went up in smoke, I put another one in, which broke everything. And now we are working with an ancient NVIDIA card, which is really slow, but it works, unlike all the other ones I've had in it. Right. So to power this thing on now, I need to get the camera back in frame. There we go. We need to solder these two black wires together, which went to the power switch around the back. So I'll just put a blob on there. Let's get the cheapest, worst fit tin we've got. Someone says dust could be the problem. I don't think dust would be the problem in this case, because it's not that dusty. It was just kind of... Ooh, this stuff has a lot of flux in it. Ooh, smoky. Very smoky. Yeah, I don't think flux dust is going to be the issue, like a device breaking issue. We can get rid of a fan. It's not monitored, so it's not going to make a difference. So we'll just snip that, snip that, snip to snip. There we go. Fan goes away. It gives us a bit more room to work. Wow, there was a lot of flux in that solder. This is very... It smells lovely in here now. Okay, so I want to start This thing has been worked on by human hands. Let's see if I can get a bit of a close-up. We're going to be awfully out of frame. This seems to have been hand soldered at some stage, because we've got flux residue, a small ceramic cap there. I want to make sure that's not shorted. Let's get better light in here, a bit of an angle. There we go. So since we've had human hands touch this, I want to make sure that cap's not shorted, because that could be, that's typical. Caps shorting out after you touch them. Well, that meter is entirely unreadable. Let's just make sure. No, not shorted. That's good. So something I'm furthermore noticing about this is that this solder joint really does not look happy. It looks cracked. It's not a plated through board, so that could suggest that we could have further failed solder joints on this. Where is my magnifying glass? There it is. Is this actually bad? Yeah. That's... No, it's not entirely confirmed. This could either be... They sometimes put little, like, flower-shaped pokey bits through the holes to prevent solder joints from cracking on heavy components. You can see they've got them on the caps there, making the solder joints all beefy and jagged looking. So I like 50-50 whether or not that's the case here, but we're going to see if we put some... Ah, yeah, this has one of those pokey through bits, so that's not going to be an issue. That solder joint was fine. Still though, I am kind of expecting a leaky something, because the power supply behaves as if it is being overloaded, because the fan spins at a rather high speed before it shuts off. So it's as if we've got an overload on some rail. People keep pointing out the standby circuit, which is a thing we should definitely check out, because that's going to be powered 24 hours a day, and all the components there are going to see much more use than all the others. And this choke is not tacked down very well at all. Jeez. Do I have failed solder joints on that? That is worth checking out. To check for bad solder. Ah, yeah. That does look. Oh no, maybe not. The solder joints are very shiny on this thing, and it isn't that common to have bad solder joints on these more modern devices, but these do. I'm torn. They could be failed, they could not be. They don't seem to be moving when I poke it, which does hint. No, I think these are good. I think they're good. I think I'm just seeing what I want to see. The way you tell a bad solder joint is if you have a small ring around the component, like poking through. But another symptom is, of course, if you move a component which is attached by a failed solder joint, the leg of a component is going to be moving. It's not going to be stuck down as well as it should be. But when you're visually inspecting for them, it's very easy to mistake reflections for cracks. But even in a case like this where I'm just suspecting bad solder joints, I'm just going to reflow these anyway, because it takes 2 seconds and I am safeguarding myself. It doesn't have any negative consequence. It just takes a slight amount of time. Again, I don't think these solder joints are bad. but it doesn't hurt redoing them. There we go. A couple seconds spent to safeguard from a possible issue. Another row of solder joints which are worth checking is this one here, because this is a big riser board. It's not very well supported. You can see it flopping around. So any load from moving this thing around, thermal expansion and so forth, is going to put these solder joints under more stress than most of the others. But they look okay. I'm not seeing any obvious issues with this, so I think we really should power this up and probably measure the 5V standby rail, because that could very well have issues. Then we're going to measure the PFC circuit, make sure the boost is right, because the PFC circuit always fails. Just seems to be the way of a PC power supply. So which one? It's going to be blue or purple if that's a 5V standby. I never remember which. We'll just plug it in, keeping in mind that we've got 230 volts exposed all over this, and this is our ground flopping in the breeze though. This isn't particularly safe. I'm also going to keep an eye on the power meter. Oh, and do note, when I'm doing this, I have turned the power off for this power plug, and I've got a monitoring light for it, so this is entirely dead. There's no power at all. I'm not about to fry myself, don't worry. But, you know, don't do this if you've got power in the cord. That should obviously be a very bad idea, because you've got mains in your fingertips, which is painful and deadly. Oh wow, 100 people watching this. I wasn't expecting that. Anyway, let's squeeze everything in here and make an attempt at measuring the 5V standby. I hate probing ATX power plugs. Yeah. No shorts to anything. Power on. Is drawing 1 watt in standby. So let's see. That's purple. I think that's 5V standby. That's looking pretty okay. What's blue? I think that's like -12 or something. The power on signal is fine. And what's grey? What more colours do I have to check? I mean, I'm not seeing any obvious issues with the power supply in standby. We've got a decent 5V standby, that's about it. It's not overvolting, it's not undervolting, it's looking just fine. Someone says standby is purple. Well, good, then we're probing the right thing. So, it's not looking abnormal at all. I don't think the 5V standby is going to be the issue. And because someone's going to ask, this is just water. Sorry. Let's just measure the other rails while it's powered on. So let's turn this on. I think it turned right off. Oh yeah, it turned off in a second. It just died instantly this time round. We lost 5V standby. We lost everything. It just turned off completely. That's like overcurrent protection behavior. Someone says checking ripple would be interesting. I would not imagine this thing having issues with ripple or capacitors, because we've got brand name caps everywhere. Sure, brand name electrolytics do fail after a long enough time, but this thing really isn't old enough for it. I think it's like a year 2014 model or something. I'm not sure, I don't think we have a date on it. Perhaps we can get some idea of its age from one of the chips. 1201, so this is going to be like, oh yeah, 1217. So this is a 2012 unit, so yeah, it is 5 years old. It could be dying from age, but I don't know, caps in this, it doesn't seem likely. It just intuitively does not strike me as likely. Someone says no fan protection. I would not imagine so, because it's using a 2-pin fan. This is the fan, this is the connector. It could have a current sense for a fan, but that seems like a needlessly expensive way of doing it. However, we can plug the fan in and see if it changes anything. It would be silly to be diagnosing this thing with no fan connected if it actually does have some kind of monitoring. There we go, fan connected. Let's just read the 3.3 volt rail while we turn it on. So main's on, 3.3, it's a bit high, and it's drawing 30 watts. Like, it turned off again, of course. It's drawing 30 watts and then it turns off. And yeah, 30 watts is way more than something like this should be drawing under no load. It doesn't stay on for long enough to make me suspect. It doesn't stay on for long enough to allow anything to get hot either, which is a bit of a concern, because it makes it difficult to know where to start. We could bring out the cheap IR gun, but I don't think that's going to tell us a whole lot, because most of the components here are going to be so high thermal mass that we're just not going to see anything. Yeah, I'm just seeing completely uniform temps everywhere. We need a thermal imaging camera. Could be an issue with fan control. This seems to be linear, but I don't know. That doesn't really seem sane. I don't see how the fan controller would draw 30 watts. Could be a dodgy rectifier. Could be a dodgy cap. Could be a dodgy anything which goes across one of the output rails. Let's measure the 5 volt as well while turning it on. So we're measuring the 5 volt rail. Let's turn the power on. See what happens. The 5 volt rail is not super high, not super low. I do kind of want to check the PFC circuit at this stage though, just to make sure. But if the PFC circuit were the issue, I would expect it to be drawing power even in standby, because the PFC circuit, I believe, is powered on all the time. But we will check for that. So we're going to be measuring across the big caps without putting 230 volts everywhere. So these were two big caps. For the PFC circuit, we should have about 380 volts-ish across them when the unit is plugged in. However, they don't have much of a bleeder resistor. Let's just turn it on. 336. That's a bit low. 336 is usually what you get if you just rectify mains right away. But it could also be a design which stores which just rectifies straight into the big caps. Those exist as well. And it could be a design which doesn't enable the PFC circuit until it's turned on. So let's turn it on. Oh yeah, there we go. Turn the power on and the PFC circuit enables when we get about 400 volts. So I don't think the PFC circuit is a problem. I just wish it would stay on for longer so that we'd know which part is getting hot, because something has to be getting hot in order for it to draw 30 watts. Quite cryptic indeed. Now I'm going to bring out the weird proprietary ESR meter and just probe across a couple of caps, because, well, actually we don't even need that. We can just measure the resistance across the output caps to gain an idea of where our power draw might be, because we wouldn't expect to see more than perhaps you know, and it should measure in the order of kilo ohms. If we see much below that, really we've got some kind of issue. So that's charging up. This is a 16 volt cap, so this is going to be on the 12 volt rail. Yeah, that's probably okay. And these three are in parallel. We've got another cup over here. Seems to be charging up just fine. I basically just want to see the meter jump into 5k range. Yeah, there we go. That's decent. Now we could just, to make it easier, know what we're measure across the plug, because these just go straight to all the outputs. So we'll just shove a negative probe into a ground and measure with 3.3 volts. This is going to have the most capacitance, so it's going to take the longest to charge. 70 ohms. That is relatively low. Now we need to keep in mind we're dealing with a 3.3 volt supply, so I'm just going to quickly calculate the current that's going to be flowing through a 70 ohm resistor and see if it's way too high. Up. Ohm's law, 3.3 volts into 70 ohms. That's just 50 milliamps, so that's not really much to be concerned about. It's less than a watt of power. Someone in chat says discharge the caps first. That doesn't really matter for what we're doing here. The output caps are going to be discharged pretty much instantaneously when you turn the unit off, and the input caps, well, we just measured the voltage across them, so it doesn't matter if they're charged or not. The unit isn't going to be running when it's not plugged in, so there's just no point doing anything about discharging the caps. Of course, we do probably have a relatively high voltage across the input caps here, the big 400 volt caps, so you don't want to go poking your fingers across them. That would be a bad idea. Well, a good idea if you like pain, but I don't. Let's just keep measuring around. Let's do 12 volt rail. I think we already measured this, since we did measure across a 12 volt cap. And I think this is okay. It's going to jump to 5k range, and yep, that's good. And we've got 5 volts in that pin there. That seems 160 ohms. Again, over 5 volts, 162 ohms isn't all that much. That could very well be by design. I'm going to do a quick calculation just to make sure. 160 ohms across 5 volts. Yeah, 30 milliamps, 0.15 watts. That's not enough to explain the giant power draw we're seeing when this unit is turning on. So I don't think that's going to be an issue as well either. Let's measure the purple. That's going to be negative 12, I think. And that's just confusing the meter because we're measuring the wrong way around. Grey, I don't know what that is. Per good maybe. Yeah, 112 ohms, but that's not going to be a supply out, I don't think. Blue, 5V standby, measuring high resistance, not any static load on that, and I think that's pretty much all the pins. We did not gain too much from that. Let's measure blue in its correct polarity, just to make sure. Positive there, and negative into blue. And that's high resistance. Someone says -12 is blue, and then thank you chat for keeping me up to date on my ATX wire colors. I never bothered memorizing those. So from measuring the resistance across the output caps, we really haven't gained much, except we know that there isn't something dead short across them, which I suppose could be a good thing. It does give us more things to troubleshoot though. It means we really just don't have any real direction to go, and we just don't know anything. This is a bit annoying. I was hoping we'd find some obvious issue right away, but that is not the case. It is annoying with these PC power supplies with the giant wire bundles. It's almost impossible to access anything underneath them. I'm just looking for anything which could be visually wrong. And the only things which really could be dissipating the amount of power we're seeing without bursting into flames are the devices mounted on the heat sinks, which is not fun because those are annoying to work with, annoying to get out. Annoying indeed. We could just measure the diodes, more or less, the rectified diodes on the secondary. They are a relatively common point of failure. And two ways who aren't aware of the rectified diodes are these guys on the secondary side heatsink. These are going to be the PFC switching transistor and the main switching transistor, and these are going to be the rectified diodes on the secondary. So let's just get at it. I'm just going to assume that their normal layout with the cathode in the 82 pins and the anode in the inner pins. And of course we've got a couple of which are just 2 pins, but what you going to do? We'll just have to make educated guesses as to what the pins do. So this is one of them. I'm just kind of looking for a diode drop in one direction and a open circuit in the other direction. This one is of course over a giant capacitor, so it's going to take forever to actually charge up. We would expect just about 0.2 volts. Geez, this is taking forever. That could be the open side, no, the diode side, so let's see. This one goes above. This does measure weird if it is actually a diode, but then again we actually have no idea what we're actually measuring. The annoying part of working with things you don't really know how that's put together. There's just no way for you to know what you're trying to find out. We could diesel the whole heatsink thing to get a better idea, but that would be very annoying and take a fair amount of time. Could you quickly recap what the symptoms of this PSU are for those of us just joining? Sure. The symptom is it turns on for a few seconds, it's drawing quite a bit of power while it's powered on, and then it turns off again. Quite a bit of power being about 30 watts, which is more than you would expect an idle power supply to draw. And I have no idea whatsoever as to what's causing that. All the voltages seem to measure pretty okay while it's powered on. Perhaps the 3.3 volt is slightly higher, but I don't think that it is. It doesn't seem to be turning off due to over voltage protection. It seems more like over current protection on some part. Also, this thing has been worked on by someone at some stage, which is not a good sign. It has a I don't like the really mongood capacitor here. It doesn't instill me with confidence. The annoying part is it works so well while it's working. We're not missing a rail, we don't have a dead short anywhere. Nothing is catching on fire. When things go on fire, it's usually easy to troubleshoot. But the PFC circuit is working fine. The outputs are providing decent voltages. It's just turning off. So this could be something really annoying, like a resistor which has gone open circuit over time and is not providing proper feedback to the protection circuit. But sadly, when you get an issue like that, tracking it down is going to take so long that it's never worth it unless it's a super duper specific or high-end device, like some industrial thing which you cannot buy a new one of. Generally, working on a PC power supply, it's not worth it putting more than a couple of hours of work into it, even if you're doing it as a hobby. Because this thing costs what? 150 euros for a new, much fancier one. It's just not really worth any time, which is a shame. A shame indeed. The solder joints do look fine. What's this? However, it seems to have some residue on this track here. This almost looks kind of burnt. And the solder mask has, the solder has come off there. That could potentially be an issue. How does that actually look? Oh yeah, that has been burnt. That's odd. It's all corroded and burnt. Let's see if I can get you guys a bit of a better shot of that. It is not so bad that it could not be a manufacturing defect. But this right here does not look like a happy piece of a circuit. Well, you can't see anything through that. I'm going to have to check the continuity there, because it's, yuck. It's looking dirty and horrible. But it is a very fat track. I don't think it's an issue. It's on the primary side though. So I'm just going to measure continuity from there to there. It's going to be perfect. Yeah. 0 volts of drop. Now could that corrosion be conducting somewhere? Let's just clean it up for a sec. Again, I don't think this is the issue. I think it's a red herring. Ah, crap, I've got my isopropyl alcohol upstairs. We'll have to just spill some from a big bottle. This is going to make a huge mess. There we go. Good enough. Let's just scrub this and see what we get. It really has been toasted though. That is a bit weird. A bit weird indeed. But all of those 10 traces there are in parallel. It's just one track, I think. Yeah, it's just one track, so it's nothing. But it does look awful. It does look really awful. I mean, that is green with corrosion. Really ugly. But it's not going to be an issue. No, I'm measuring that. There's no resistance in this at all. It's fine. Just ugly. But these things don't have to look very good, as long as they work. Let's just absolutely triple, quadruple check that that is the same track as the other one. Yeah. And the trace is looking fine. So there's just, it's a red herring. It points to, manufacturing quality issues. That ideally shouldn't happen, but this is a cheap consumer thing, so things like that do happen from time to time. Usually they're not bad enough to break the product. That's why you got warranty. This thing clearly lasted the warranty. Let's get you guys back to the wide. There we go. Do we have anything other here looking as bad as that? No, nothing's really looking too bad, really. I'm afraid that in order to fix this, we would have to really dig into it. We'd have to start checking datasheets and reverse engineering it, and or going component by component, and that's not something I'm prepared to do for this thing, sadly. What a shame. I think this thing is trash. That is a shame. But at least we've gotten a bit of an interesting troubleshooting out of it. You know what? I have in my mind now relegated this to trash status. So let's just desolder the secondary side rectifiers and measure them one by one, just in case the issue lies there. And even if the issue doesn't lie there, I want to take that off anyway, because I use these rectifiers for all kinds of stuff. PC power supplies are a good source of high current diodes, which are, relatively expensive if you order them. So this is just going to be a question of desoldering this row of stuff here. There's like 2 mains for the heatsink and a million mains for the actual devices. Someone says use an infrared camera to check the hotspots. Well, I don't have one, and they are very expensive. I wish I had one. They are incredibly useful tools. But you can't have everything in life. As far as cameras go, I more than anything just like to get my bloody video camera back. I don't need to have more camera trouble until I've got that one sorted. And now you guys are going to be listening to this cow going for quite a while. Using these desoldering pumps is a bit of a finger feel thing. It's difficult to explain how to do this properly. The first few times you use them, you're going to be absolutely terrible. But I do recommend having one of them. Basically to anyone doing like more heavy duty electronics repair. Because trying to desolder something like this with more traditional equipment just would not work. Now what do we actually need? That's gonna have to go. Are we in frame? Yeah, we are in frame. Important thing is to actually move the pin around like this. Because if you just hold the desoldering pump steady while you pull the trigger, the leg is going to make a sweat bond to the solder joint and it's not going to get desoldered at all. And it's also important to add, usually important to add just a tad of tin to make the thermal bridge. I didn't add enough there, so this is having trouble melting. Add more solder. Counterintuitive to add solder to stuff you're trying to get desoldered, but that's the way the world works. So add a bit of solder, wiggle it around more, pull the trigger. God, come on. On an unrelated note, I have considered... Come on. That's a bit too thermal mass. Too high thermal mass. Yeah, on an unrelated note, I have considered trying to put together a bit of a repair basics video series once I get the proper camera back. Because I think there's a fair amount of this stuff that's not entirely obvious. Like just how to use your tools. I'm sure someone has already made one which would be of higher quality than anything I can put out. But it could be an interesting exercise to produce it anyway. Just quick videos telling you how to do basic electronics repair. Basic electronics repair. But we'll see. I am a very non-committal person, so could happen, could not. I still need to edit the entirety of the Van 2017 series, which I have been postponing indefinitely because I am very, very lazy. The sounds of solder falling into a trash bin. Oh. Yeah. I threw away my solder collection spring there for a sec. That's not very clever a thing to do. There we go. Clean as a whistle. Oh dear. This one is not clean as a whistle at all. It's in fact full of garbage. These desoldering pumps are a lot of maintenance. Constant filter cleaning, constant emptying, constant everything. But they save you so much time that it's really worth it in the end anyway. That's better. We've got suction. Right, yeah, let's just keep desoldering. What's the chat say? Would love to see that video. Please make a repair vid. A repair vid of what? I don't understand how people like Liz Rossman can go through and read every single comment. Because I can't do work while reading comments. Oh well. This is going well. I like them. Another thing about these desoldering pumps is they basically don't work on multi-layer boards. Well, they kind of do if you really get the practice in and you don't have a very heavy board. Because they don't have a great thermal capacity at all. None of them do. Not even the fancy brand name ones. So they meet their better part if you try to solder like a PC motherboard. Good luck with that. Is that another? Yeah, that's another part. This thing has a shit ton of rectifiers. We're not even halfway through yet. Come on. Moo. Come on. There you go. Oh, helps be in frame as well. Not that this is particularly exciting content. Welcome to the Man Desoldering Many Things podcast. Maybe we'll learn something at the end of it though. That's not impossible. Yeah, we've got these 6 joints here to go and the big ones holding the heatsink in place. After that, I think the rectifier heatsink should pop out and we can actually measure the diodes. I don't really think the diodes are going to be bad. I'm just doing this to pad the stream slightly, since else it would have just been an entire disaster. To those of you who are just joining, I've pretty much given up on repairing this thing because we went through all the basic checks and none of them had any results, so I've made the judgment call to pretty much scrap this thing, because going further would entail basically going component by component or trying to reverse engineer it, and that would take so much time. I'm not willing to spend it, sadly. This is just an 80 plus bronze PSU from like 2012 anyway. Someone says your tip looks a bit big for the job. Are you referring to the hole? I wouldn't think you are, because you haven't seen the hole before. You don't get these with different tip sizes. And consider that the tip needs to go around the pin. So it has to be quite fat by design. You can't just have a tiny little tip, because then you wouldn't be able to either fit the pin in, or you'd just have a tiny amount of thermal contact area around it, and that just wouldn't work. The my pump is an AOE something or the other, and these do have slightly fatter tips than, for instance, Heiko's do, and I actually prefer the fatter tips on the AOEs, because on these, if we can maybe get some focus. Yeah, that's not going to focus at all, is it? I don't want to burn my hand either. But on these, you have a relatively large area around the actual pin you're soldering. If you have a smaller tip, you get a much smaller area there and you can't transfer as much heat into the board. So this one's got a higher thermal capacity than, well, the Heikos, for instance, which have a smaller tip. And that just makes them so much easier to work with. I have used both. We've got Heikos at work. Alright, now we've just got the big ones which are holding the heatsink in place left. And then I think we're good to go. I think this is going to just pop off. Let's see if we can pre-solder this a bit and then use the desoldering pump to suck it dry. And the answer is no, that's not going to work at all because the pin is way too big. So we're just going to have to kind of rip the heatsink off by using force. Screwdriver underneath it. Oh, that's perfect. I'm going to apply some force to that. Put some more tin on there. Now, this should, in theory, bend out rather easily. But it isn't because we must have forgotten. Oh no, it's got even more. I think this pin is also holding it in place. And that one I think we can actually desolder with a pump because it's not ridiculously giant. We do need to preheat it with a proper soldering iron though, because it's a very high thermal mass since it's connected to the actual heatsink. That did not work at all. Could be a work for solder braid, that one. Where's my solder braid? There's my solder braid. And for solder braid we need additional flux. Because trying to use solder braid without additional flux is pain. There we go. One side relatively clean. This pin is a very, very tight fit in the hole. So get the solder off it is gonna be a bit annoying. We've got three sides clear, the left one's the one left to go. Come on. Suck it. And we've got a bit of a sweat joint on that side there, but I think it's gonna give way if we use a bit of force without damaging the board too much. So we'll just use the screwdriver to bend this again. Yep, there we go. Oh no, we actually ripped we ripped the pin out of the heatsink. Oh well, I don't quite care. That does not make a difference to me. And now the real question is how the hell do we get this one off, because I don't think we can access to actually pry. Maybe we can pry the heatsink up. I'll just get it like... We'll jam it through the big pile of goop and we should be reasonably able to pry that up. Yeah, that should be able to provide enough leverage. And some tin on the big heatsink mount and we should be good to go. I don't think there's anything else keeping this heatsink on. Nope, there we go. It's free. Save for one temperature sensor. That could be an issue actually. If the temp sensor is broken and it thinks that it's running way too hot. So we could measure that as well. Could even be so simple as to a broken lead or a disconnected connector on it. Yuck, thermal paste everywhere. I do like how they've actually put little ferrite beads on the legs there. That's a nice touch, reduces emissions. So how's this thing look? Is it... Where are you connected to? Two orange leads going to these pins. So that's probably going to be a 10k NTC. So I probably want to see about 10k across it. Let's measure. That's not measuring very good at all, because I'm measuring the wrong pins. These are the ones. Give me 10k. 2k. Let's desolder this and see if it responds to temperature. It could be a lower value NTC as well, of course. I haven't actually checked to see. Someone says, future video idea, opposite of a repair, create problems for a working power supply, show effects on the device. I don't really have enough trash power supplies available to not need to create problems. We've got a problem on this one. There we go, there's our temperature sensor. Now the reason I think this could be an issue is because it thermal paste everywhere. The reason I think this thermal sensor could be an issue is because it runs the fan on basically full speed when you turn it on. No, that's just a little white plastic holder. I thought it was an integrated thing. But yeah, I would expect to see about 10k across this. And we've got 10k. And if I hold those with one hand and prod my finger on there, we should see a change in resistance as it heats up. So sadly, this is not our problem. Shame. It could have been. It realistically could have been the issue. It wouldn't really explain the high power draw we saw, but it could have explained the turning off in case this power supply just draws a bunch of power at power up for no particular reason. So let's just move on to our original goal, which is to measure these guys. So these are diodes. They are usually these are all ST. We've got a couple of on semiconductor ones, but in almost all cases these are anode, cathode, anode, double diodes. So I'm just going to assume that they all are and measure them like so. Sometimes they have a reverse pin configuration, but that happens very rarely. Now this one's just not measuring anything at all. It could be something else. I'm going to have to check the datasheet for that. It is labelled NFB09, NFB09, B30, B30, H30G. What are you? According to Google, nothing. So we'll just do like B30, H30G. It says it's a rectifier. Give me a PDF. Pins 1 and 3 are anodes and pin 2 is a cathode. Okay. So this really should measure. Positive there, negative there. Oh, there we go. I was just not poking through the oxide layer. Oh crap. There go those pins. So we'll measure from there to there and the other direction. It's good. This one is not our issue. Very low voltage drop model there. And this one, from there to there, good. From there to there, good. And the other way around, open circuit, open circuit. That one's good as well. I think all of these are going to be good. Wow, 0.038 volts. They really do get very low forward voltage drop diodes these days. That's pretty incredible. That one's good as well. Open circuit, diode drop, open circuit, diode drop. That guy's good. And you are open circuit. Are you reversed? Am I measuring wrong? Hang on. This could be a FET though. So we'll short it. If it's a FET, it's going to be gate drain source. Like always, so shorten the gate. Like this could potentially turn it on. So now we should see a low resistance there. And we just poke our fingers there to discharge the gate. And this should now be open circuits. Yeah. Pokey, FET on, pokey, FET off. So that's a FET and it's working fine. Move on to the other side and we're going to probably have a row of other well-working components. Is this another FET? Does look like another FET. Pokey, and it turns off. Positive voltage on the gate, and it turns on. It's in good nick. Now this one looks different. It's probably diode. Are you a diode? What are you? You are. Oh man, this guy's hard to read. STPS. Oh, geez, this is impossible. STPS 61L60CT. That does sound like a diode. So I would expect that to be a diode. Are you a diode? Yes, you are a diode. And you're measuring fine that way, with no leakage anywhere. Another working component. And what are you? Are you a diode? Are you a diode? Yes, you are a diode. And you're working just fine. Indeed. Another working diode. Just 2 more possible failure points to go. I don't think our issue is going to be here. But then again, I never did think that. We're just doing this for a bit of fun. Nope. Good shape. Measure that way, diode drops, and nothing in reverse, and nothing in reverse. So all of these components are in good working order. They are not our issue. Oh, that's a bit of a shame. I wasn't expecting a fault here, but I was hopeful because these are power components. Power components are power components are the most likely components to fail. But that really means that we have got a much more cryptic issue on this. And it's beyond economical repair. Sadly, this thing is going to the scrap bin. But rest assured, I am going to scrap it very well, because PC power supplies are excellent for picking all kinds of random bits and bobs out of. This thing has a working PFC circuit, meaning that I can rip pretty much all of this stuff into another one, and the PFC circuit always blows up when you have bad power grid stuff. If you have a badly inserted power connector or something, the PFC circuit is going to go. So this thing is going to be very useful for parts. The transistors and diodes associated with a PFC circuit as well tend to be quite expensive, and I have to order them from Mesa, so it takes forever to get them here. So it's not a complete loss, it's not a fix either, but hey, what can you do? We gave it our best shot. And with that, I guess I'm going to have to thank you for watching, and I'm going to close this stream and enjoy the rest of my Sunday evening. You guys take care. I hope I'm going to be back with more content once I get my bloody camera back. And I'll see you around. Cheers.